Assalamu alaikum learners, welcome to the robotics class. Today we are stepping into different slides on robotics world, that how we can establish a virtual robotics lab. We love getting our hands-on experience with the microcontrollers, sensors and all the things. But today we are going to learn that how we can build, wire and write code for robots entirely on screen without touching physical components. This is what the virtual lab actually means. So first thing is this, that why we need virtual labs. Okay. So why we are simulating, and why not we are grabbing an Arduino and start plugging things in. First thing is this: the hardware is costly and needs a lot of money, and you can make mistakes if you are beginner. And if you wire a real circuits backward, you might pop an LED, or you can fry microcontrollers. So virtual labs gives a sandbox to make those mistakes very safely. But it goes deeper than that. Sometimes we need a very advanced level hardware, and obviously we cannot get that things in your like area, or you can say that in your home. So virtual labs basically allow us to do all these type of things without any trouble or need of money and availability problem of components. So there are many tools for that, and we will definitely look into them, that how we can use them to create a very productive and you can say that circuit that can help us to create a real world scenario or machine. So these are the major tools that we will use in further classes. First one is the Tinkercad, second one is WithDiode, and third one is Fritzing, and fourth one is Proteus. So Fritzing and Proteus are a little bit, you can say that the advanced virtual labs where we can have access to many more advanced type of controllers. So Tinkercad is basically entirely cloud-based, and you can also download its web, you can say that offline variant, but that is also limited. So you do not need to install anything. You can drag and drop components that look exactly like the real world components, and it supports both block coding and C++. So if you are a beginner and you have no previous experience with the programming, you can use block coding. So we will look at how this thing actually works. And second option is that WithDiode. WithDiode is another website. It's a very rapid prototyping. You can say that a thing. When you just need to know that with the code this thing is working or not, and with right microcontrollers and right wiring and all type of things, so you can use that with diode as well. So let's see that how they look and how they work one by one. So okay, so if I just search Tinkercad on Google, so here it is, the first one. I'm also having its offline variant, but we are going to start from very beginning, so we'll use that Tinkercad online variant. So uh, at the very beginning it will obviously ask for the account, and you have to create an account, or you can sign up with Google. So we are creating circuits, so we will select circuits from the create, and here it is. So you can drag drop all type of components like LEDs, resistors and all type of things without any you can say that hesitation. So let's connect one basic circuit to see that how it works. You can change the wires color from here. Okay, let's start simulation, and LEDs obviously glow over here. So this is a very simple tool, and here is a components detail. You can get basic Arduino, microgrid, circuit assembly, and all type of components. So here's a detail, and you can find the components by their shape and picture as well. So second option is with diode. Okay, so this is with diode's official website, and obviously this is the first time I'm doing in this tab, so I'll need to sign in or sign up. So if you are having a Google account before this, you can just sign in or sign in with Google. Okay, so here we are. If I just create a new project over here, I can get all type of components over here. So already the breadboard and a battery is over here. So let's get a resistor. We can place the resistor on breadboard just like we do in the real world, like this. Okay, and we can grab an LED, and we can also place that over here. Obviously you can change its camera angle, so we'll do that from here, like top to bottom, left to right. Okay, so here we are. So this is our LED, and we can see the resistor is not rightly connected, and we can use another wire from wire. Okay, so from the negative, just place it over here. So it's just like the real hardware. So you can see that LED is glowing, and if we see the side scene, we can also see that from different angles, right? So this is how the WithDiode works, and there are a lot of options over here, like different types of ICs, capacitors, breadboards, batteries, and all type of things. So you can use these type of components to create the circuits of your own choice. So let's go back to our slide and see what are the other options. So the third one is fritzing. So let me show you the fritzing and how it basically works. So we don't need the with diode right now. So let's close this. Okay, so yeah, here it here it is, the fritzing. Fritzing is another tool where we can simulate the circuits, and it's also having a lot of components over there. So let's get start with an example. Let's go to the file, open example, and Arduino and light. So LED blink, yeah. So we are taking an LED and Arduino to show that how it is blinking. So this is the main circuit over here, and we can see the code from here, and obviously we cannot just simulate like the real circuits over here. We need the higher version of that, and I'm having currently the previous version. Otherwise it shows over here start simulation just like the Tinkercad and WithDiode. So this variant is not supporting the simulation, but you can see the circuit over here, and if you want to screenshot that and use in your assignments or anywhere else, so you can definitely use that. Okay, so the fourth one is the Proteus. So Proteus is another tool where we can set up virtual labs. So here is the Proteus. It's a little bit, you consider the advanced version of the virtual lab. So mostly our work will be done on the Tinkercad and Fritzing and WithDiode. So we will not use that, uh, on the daily life. So if we need a higher end, like if we need a very advanced type of hardware, so we can use that. So there are many options of diodes, ICs, and all type of things. So inductors, electromagnetic things like ICs, capacitors, and all type of things. So if you need capacitor, you can get that from here and place that over here. But you can see that this is not very attractive. This just shows a symbol of capacitor and not showing the whole capacitor and all type of things. So we will not use that in you can see that the daily life. So let's just close this. No. Okay. So this was the basic introduction to all the components, like all the, you can say that the virtual labs, Tinkercad with diode, Fritzing, and Proteus. So how do simulators work? So let's just see this thing. You can see that the simulation tools mostly analyze each type of things, like on that we can get on the hardware, like the voltages, current, and all type of things. So how do they know? There is a physics, you can say that engine behind that engine, that you probably are familiar with the games, that games usually have physics behind them, like the gravity and all type of things. In the same way, these virtual labs are also inbuilt physics engines. So are having basically in physics engines. So these physics engines help them to understand the calculation of voltage, current, resistor in the real time. So the microcontrollers like Arduino and all type of things, obviously they need a programming, and so we can also add the programming on that you can say that circuit. So if I just open the Tinkercad, let me show you a very basic thing related to this concept. So if I'm having Arduino over here, I can go to the code section and see that block coding over here. So this is a loop, that for our loop, and it sets the built-in LED to high. High means on and low means off. So it will on for 1 second and off for 1 second. So this is the programming, and if I want to see the exact code, so I can also select the text over here, and it will show me the exactly code that's behind this block code, and we can use that code in a real life as well. Like we can upload that code in real hardware of this Arduino board. So okay, so let's just try to simulate a circuit over here to understand things more, you can say that easily. So let's get an LED from here. So this is LED, and if I connect that LED without a resistor, so it will burn. So let me just show you. Obviously it's a simulation tool, so we have no concern whether it is burning or not. So we are not into something like damage or any type of. So you can see this is showing the burning of Arduino. So it means that there should be a resistor in between, and also you can see that it's showing that it's having more current than usual aspect. So let's get in resistor from here. Okay, and if I place the resistor in series of this light, you will see that it's running perfectly. So this is basically because of that physics engine that is behind this all, right? So yes, so we will start with you can say that Tinkercad, and sometimes we will use the WithDiode, and if some cases where we need a higher microcontrollers, higher ends of microcontrollers like ESPs or other type of controllers, so we will use the Fritzing as well. So Proteus we will mostly not use that, but in case there are components that are not available in these three, you can say the tools, we will definitely use Proteus as well. So you can obviously get the code from here to see the IR sensor and obstacle in front of that. So it will calculate and show you it will definitely calculate and show you the distance, that how far are you from that sensor. So these are some applications of virtual labs, and these are some troubleshooting tips that you can read. So this is main thing, that simulation versus reality difference. So simulators ignore real-world electrical noise and lose wires. So obviously sometimes you just plug the wires in, but they do not work. Obviously the physical contact and all type of these things matters a lot. So sometimes these things like noise. Noise means that there is external factor that is affecting our circuit. So sometimes these things that we face are only in the reality. So in virtual systems they are not considered as like the real one, but they are very close to that. So obviously we can get a very deep knowledge about each type of circuit and all type of things. So second thing is physical constraints. Virtual motors do not struggle with heavy robot chassis or friction. Obviously friction is also a main part, where if you make a robot and it's heavier than ordinary robots, obviously there is a problem of friction between the tires and the ground. So sometimes the virtual systems ignore that. Obviously not completely, there is a physics engine behind that. Obviously they will consider the friction, but not exactly like the real one. So you can just understand that by this example, that if there are tiles in your floor and if there is a rigid surface, so obviously the friction is different. So on the simulation there will be a simpler, like a single friction constant, like whether it's a tile or whether it's a rough surface. So this is the main difference between them. So golden rule is always treat the simulators as a step one, and the step two is validating on the real hardware. So this is a summary of today's lecture, and that's it. Thank you so much, and we'll see you in the next class, and we will build some very exciting circuits with these you can say that uh, virtual robotics labs. So thank you so much. Allah Hafiz.